Hello, corporate finance students. This is going to be a sequel to the future value, present value video from last week. And we came up with a few equations in that video. So what is FVSS? That's future value of a single sum. You put X amount of dollars in the bank for so many years, that's the N, at a specified interest rate. It's going to grow to become a larger amount. That larger amount will be equal to the present value times the future value factor for a single sum. Okay. Similarly, if there's a pile of dough out there in the future, pot of gold at the end of the rainbow, and you want to know what's it worth today, you want to know what the present value is, you would use a present value factor for a single sum, which would shrink that amount of money into today's dollars. So these are both for one-time investments or receipts over a period of time. Now annuities, what's that? Ordinary annuities is what we're dealing with. That's going to be an equal amount of money paid or received at the end of each of the next X number of periods. So we start at the end of the first period and then go forward from there. So let's say you put $10,000 in the bank every year for 20 years. How much money will you have at the end of 20 years? So your annuity is $10,000, and you'd use a future value factor for an ordinary annuity to expand that number to the pot of gold at the end of the rainbow. Okay, now investment type people like this little equation here because they like to show you how you're going to be really rich someday if you just do what they tell you to do. This is this one's the key one, right? Most important one of all. The present value of an ordinary annuity is equal to the annuity amount times the factor. All right. So if you have, let's say, $10,000 payments at the end of each of the next 20 years, what are those 20 $10,000 payments worth today? You would use a present value factor for an ordinary annuity to shrink those payments into today's dollars. And we used this equation last week working with installment loans. So the present value of the ordinary annuity in the case of an installment loan is the loan amount. The annuity is the monthly or periodic payment, and the PV factor is the PV factor for an ordinary annuity. All right, so I created a few problemas here, and I can see that this one is spelled wrong, so I got to fix that or I won't be able to sleep tonight. Okay, here's the deal. We're going to put $10,000 in the bank today. What's it going to be? And it's going to amount to $18,509 in 8 years. What rate of interest are we earning? Okay. So we could use one of two of these formulas. This one here we'll start with. What's the future value of the single sum? That's the amount 8 years from now. So I'm going to put that over here. And what's the present value of the single sum? Well, that's the $10,000 invested today. So what I've done is plug this into this equation here. And the thing I don't know is the factor. So what are we going to do? We divide both sides of the equation by 10,000. Yeah? And we wind up with this. The 18,509 divided by 10,000 is equal to 1.8509. And we know it's 8 years, so what do? Okay, we go to row 8 of the future value single sum table. Okay, so that's what we're looking for. We're looking for a future value factor. So let's go to the tables that I sent out. Future value single sum. Yeah. 8 years. So you start over here, because you know it's 8 periods, and you go across until you find the number. I'm hoping against hope that's our number, and it's 1.8509, yeah? All right, so what does this tell us? 8 years from now, that's the factor if you earn 8%. So when you know the N, you go across the table, and then you go up to find your interest rate. Yeah? Now you could have solved this problema using this equation. The present value of the single sum is equal to the future value times the present value factor. In other words, $10,000 is equal to 18,509 times X. You divide both sides by 18,509 and you get this number here. And you could go to the present value factors for single sums, and we're looking for what? 540278. All right, so let's go there. We know it's 8 periods, right? So we go across, we find our number 54027, and at the top of the column we find the final Jeopardy answer, which is 8%. Okay, let's go back and see, why did that happen? Well, these are reciprocals. Remember, this is 1 plus I to the nth power, and this is 1 over 1 plus I to the nth power. So if you take this number here and divide, you get 540278. Yeah? That's how it works. So the reciprocals. Now that works with single sums. You can't solve annuity questions using both tables. You need to be in the right table for that. So in other words, you don't use this approach for annuities. Okay, where are we now? There's another little trick I want to show you. That number is what? We know that that number is 1.08 to the 8th power, yeah? Could you find the 8th root of this number? Well, if you take 1 over 8, you get 0.125, yeah? So what if we take this number here and we raise it to the 0.125 power? What do we get? We get this number, which is roughly, well, pretty close to 1.08. That's the interest rate, yeah? So if you're using Excel and you want to find the square root of a number, you use 0.5, the third root, 4th, 5th, 6th, when we just did the 8th root. That's how it works. So the caret is the exponent function in Excel, which is above the 6. All right, let's move on to the next question. What do we got here? $50,000 invested today, so that's a present value, yeah, the $50,000. At 5% is going to amount to 63,814. 63,814 is the pot of gold at the end of the rainbow, aka future value. 63,814 is equal to 50,000 times some number gives you that. So we divide both sides of the equation by the 50,000. We solve for the future value factor. We get 1.2763. We know the interest rate is 5%. So what do? We go to the 5% column in the future value single sum table. So let's do that. 5% column. And we go down and we're looking for our number. And what was our number? 1.2763. So there it is, 5%. When you have the interest rate, you go down that column and then you go across to find your n, and n is equal to 5 in this case. Yeah? And since it's a single sum, we could do it both ways, yeah? So what was the present value? 50,000. And the future value is 63,814. And that gives you this factor, 78353. You go to the present value table and look for that number. And there it is in the 5% column. 5 periods. So n is equal to 5 is the final Jeopardy answer. Yeah? Okay. Let's see, what else do we have here? $20,000 invested at the end of each of the next 10 years is going to amount to $234,628. So that's an amount that's out there in the future. And that's the future value of an ordinary annuity. Yeah. So we know the annuity amount, that's 20,000. We divide both sides of the equation by 20,000. We get this number, 11.7314. We know n is equal to 10. So this is a future value factor for an ordinary annuity. We're going to go look in the future value ordinary annuity table. We're going to go across row 10, look for 11.7314. Let's see if we find that. Future value annuity table. N is equal to 10, right? And there it is, 11.7314. What's the interest rate? 3.5%. So you know the N, you go across, and then you go up to find your interest rate. All right. Next on the hit parade, what do we got here? $25,000 is invested at the end of each year at 6%. How many years will it take for the annuity to grow to be 472,053? All right, so 472,053 is a future value of an ordinary annuity. And we know the annuity amount, again, is 25,000. We divide both sides of the equation by 25,000. We solve for the factor. And we get a factor of 18.88212. And we know it's 6%. So we're going to go to the 6% row in the future value ordinary annuity table looking for this number. 6% row. We go down. Bingo! 18.8821, which is on row what? 13. So the final Jeopardy answer is 13, yeah? It will take 13 years of $25,000 payments to get to this number at 6%. Okay. Here's another one of our Corvette deals, right? Did one of these last week. So Ignatz needed a new Corvette. He borrowed $80,000 to be repaid at 6% with 20 monthly, with a 20-month loan. Okay, it's an installment loan. Okay, what is his monthly payment? So the present value of the ordinary annuity is the loan amount. That's the $80,000. Now we need a factor. But you're not going to look up 6%. You're going to look up, since it's monthly, you're going to look up 1/12 of 6%, which is 0.5%. So 20 monthly payments at 0.5% or 0.5%. So we'll go to our present value ordinary annuity tables and pick up that number. Number is n equals 20, right? 18.98742. Yeah? Let's plug that in there. We solve. How do we solve? We divide both sides by 18.98742. Yeah? And we get a number. And what is the number? The number is 421332. We're hoping against hope that that's the monthly payment, yeah? You're thinking, I don't believe this. This can't possibly be true. All right, let's give it a shot. We'll do a little loan amortization over here. What's the interest for the first month? It's 1/2 of 1% of 80,000. How much principal is paid off? It's the monthly payment minus the interest component. That's how much of the loan gets paid off. And I'm going to freeze that. Why? because I want to go down the page with this. So that's F81. Put a little dollar sign over there. All right, this is 80,000 minus 3813. So now we're hoping that this formula will work out for us. So we'll carry this down 20 periods. See what happens. Comes out to 0. It's got to be right. Yeah. So there it is. Ignatz, you want the Corvette? I'm going to pay it off in 20 months. It's going to cost you $4,200 a month. Okay. Next on the hit parade. Philo Kvetch borrowed $120,000, which he has agreed to repay with 12 monthly installment payments of $11,002. What is the annual rate of interest being charged? All right, so the present value is the loan amount again, right? 120. And we know the annuity amount this time. It's 11,002. So we divide both sides of the equation by 11,002, and we get this number. We get this factor. And we know that's a present value factor for an ordinary annuity. And we know the N is 12. So we're going to go to the PVFOA table. We're going to go across the page looking for 10907. Yeah? And there it is. We find 10907 on row 12, which is your N, right? And 1.5% is the interest rate. But it says what? Annual interest rate. So if the monthly interest rate is 1.5%, you want 12 times that amount. You want 18%. Yeah? To get the annual rate. Okay, what's next? Oh, Dora Debit. Dora Debit, what did she do? She borrowed $125K at 12%, agreed to make monthly payments of $7622.76. Once again, the loan is the PVFOA. The annuity amount is $7622. That's the monthly payment. Okay? Once again, what are we going to do? We're going to divide by both sides of the equation by 7622.76. We're going to get this number, 16.989827. We know it's 1%, so this time we're going to go down the 1% column on the PVFOA table. And of course it's 1%. Why? Because it's 1/12 of 1%. So we'll go down that row, that column rather, and we'll try to find this number, 16.39827. And there it is, 16.39827, and 18 periods. So the final Jeopardy answer is going to have to make 18 payments, yeah? You're thinking, this is bogus, I don't believe this. All right, let's see what happens here. What's our interest rate again? 1%. So the difference between 1250 and 7622 is going to go to principal, yeah? We got to freeze the monthly payment again and carry this down and see what happens. So comes out to a penny after 18 periods, yeah. So it works. All numbers work. So at this point, I'm kind of hoping against hope that we're able to deal with the rest of the problems, because I think 1 through 6 we could have done last week, and 10 we could have done from last week's video, but hopefully now we can do the rest of these. And we'll give you the feedback on that in a few days or so. Have fun with that.